Hello and welcome again. In the previous video, we started talking about the transformation mixed columns, which is part of the rounds. Now, what I'm going to do here is I'm going to give you an example and tell you what the mixed column does for a particular 128-bit block. So what the mixed column does here is going to take an input, of course, of 128-bit block, zeros and ones, and it's going to transform that into another 128-bit block. Now, that transformation, the way I'm going to present it here, is going to happen in groups of 4 bytes. Now, it doesn't have to happen like that when you implement the software, but it's better in terms of seeing what the mixed column is doing, just to look at it in that perspective, and meaning that I'm going to transform 4 bytes at a time. So 4 bytes of this input that I have here. So what I'm going to do is, let's look at an example. So I have here my input, and this input is 128 bits, which is this long list here, or 128 bits. Now, the first thing we're going to do is, to do that transformation, is we're going to divide it into blocks of 8 bits, or bytes. So what I'm going to show you now is that transformation. So I'm going to divide it into bytes. Here, I'm going to take the first 4 because the operation for the next 4 is the same. So you have to do this 4 times because you take 4 blocks at a time, and because I have a 128-bit block, then you have to use it 4 times. So in this case, this 128-bit block that I have here, I'm going to divide it into 4 bytes, and I'm going to take the first 4. So I'm going to this one that is right here, I'm going to call that x0. This one, that's the first byte, which is 8 bits. The second byte will be this x1. The third byte will be this x2. And the fourth byte will be this x3. So I'm going to transform those 4. And you're going to do that for the next 4, for the next 4, and for the next 4. So let's look at how is that transformation here going. So I'm going to transform this 4 bytes, x0, x1, x2, into x3. I'm going to transform that into another 4 bytes. So let's see how that transformation is. So the first thing I had to do is I'm going to take all these bytes that I have here, and I have to write down the polynomials that they represent. So if you look here at x0, so x0 is 0, 1, 0, 0, 1, 0, 0, 1. So that's exactly what I have here, 0, 1, 0, 0, 1, 0, 0, 1. Now remember, to get the polynomial out of this, you're going to imagine that this position here holds the x to the 7th power. The next one will hold x to the 6th, x to the 5th, x to the 4th, and so on. So if you actually go ahead and do this byte, it's going to correspond to this polynomial right here. And the reason is because wherever you have the ones, that's the powers you're going to use. So I have a 1 here in x to the 6th. I'm going to use x to the 6th. I have a 1 here under the power x cubed, so I'm going to use x cubed. And I have finally a constant here for 1, so I'm going to use x1. Now I'm going to use notation, and I'm going to denote this polynomial x0 also. So x0 will denote the byte and the polynomial. Of course, that's not entirely correct, but I'm not going to introduce more notation just for that. So I'm going to use x0 for this polynomial and also for the byte. You do again the same thing for x1. So for x1, you have, this is the byte 1, 0, 0, 0, 0, 1, 0, 0. And if you go ahead and transform it the same way we did with the x0, then you're going to get x to the 7 plus x squared. Because there is a 1 on x to the 7, and there is a 1 in x squared, and there are no more. Now do the same for x2. So for x2, we have this is the byte x2, 1, 1, 0, 1, 0, 1, 0, 0, which is exactly what I have here on top x2. And again, I'm gonna look at the polynomial that it represents. So it's gonna be a little bit longer polynomial because I have more ones in here. So I have an x to the 7, x to the 6, x to the 4, and x squared. And that's exactly what I have here, and representing that by x2 again. And exactly the same for the last one. So if you look at x3 there, that's gonna be represented by this polynomial. Okay, so first of all, so let's recall again. So what you take is 128-bit block. You divide it into bytes, and you're going to transform 4 bytes at a time. Now, I'm going to transform these 4 bytes, but I'm going to just look at the representation as polynomials to do that transformation. And so let's see how is that done. So remember, this is x0, that's polynomial, x1 is this polynomial, x2 is this polynomial, and x3 is this polynomial. All right. So we're gonna get 4 bytes out of it, because every time I have 4 bytes, x0, x1, x2, and x3, I'm gonna get another 4 bytes. The 4 bytes that are the output of the mixed column, I'm going to call them Z0, C1, C2, and C3 because they correspond to X0, X1, X2, and X3. So how is this transformation done? So I'm going to transform these 4 bytes that I have here into these 4 bytes that I have here, C0 through C3, in a second. So I have to know what these bytes are. So let's see. So the transformation is going to happen by matrix multiplication. And remember, there was a review about that. And so we have to review that. Now, the matrix multiplication is going to happen like this. Now, these 4 bytes that you see here, C0, C1, C2, and C3, I'm going to put them as column vectors here. They're actually going to be polynomials, but I can actually get the byte out of this. And this X0, X1, X2, and X3, that is also this column here, they are representing these polynomials that I have over here. So these are these polynomials. Alright, so how is the transformation? The transformation, as I said, it happens by a matrix multiplication, and this is the matrix that you always gonna use. This is kind of similar to what we did with that special polynomial that we have for multiplication in the Galois field. This is a special matrix, and this is it's also part of the advanced encryption standard specification. So this is a matrix that is always used in this algorithm. So as the matrix that the first entry is x, and here in this position 1 plus x, 1 and 1, 1x, 1 plus x, 1, 1, 1x, 1 plus x, and 1 plus x, 1, 1 and x. So I'm going to multiply this matrix by these things that I know, x0, x1, x2, and x3. Alright, now this is a good moment actually for you to write this down, because this is as important as the polynomial we saw earlier for multiplication. So if you want, you can pause the video here and write down this matrix because you're gonna need it for computations. All right. So once we have this matrix, remember this matrix is not gonna change for the bytes. The only thing that's gonna change here are these bytes over here. All right. So let's see. So because of matrix multiplication, I'm gonna do only Z0 because if I have to do all of them, I'll have to multiply. I have to do these 4 bytes, all of them. I'm gonna do only Z0 here because once I do this one, you will see how to do the other ones. So what I'm gonna do here is I'm gonna multiply. If I want to obtain Z0 here, I want to multiply this row that I have here, x, 1 plus x, 1 and 1, multiplied by this column that is right here. So remember, from the review of matrix multiplication, you're gonna take x multiplied by x0 plus 1 plus x multiplied by x1, 1 multiplied by x2 and add it, and 1 multiplied by x3 and add them. So I'm going to write down this row times this column. So if I do that, then Z0 from matrix multiplication, we're going to have the following. This Z0 will be Z0 that is right here, this first byte, will be equal to this row times that column. So if I write that down, then Z0 will be x times x0, which is exactly the same as I have over here, x times x0, then 1 plus x times x1 plus 1 times x1 plus 1 times x3. And that's exactly what I have here. So x times x0 plus 1 plus x times x1 plus x2 plus x3. I didn't put the ones in there because if you multiply by 1, it doesn't do anything. So you just have to write down x2 and x3 there. Now once I have that, I have to go ahead and recall what this x0, x1, x2, and x3 are. Now remember, those are the polynomials that correspond to the bytes I'm trying to transform. If you go back here, x0, let's go back over here. So x0 will be this polynomial, x1 will be this polynomial, x2 will be this polynomial, and x3 will be this polynomial. So I'm gonna replace them over here. So I have this. I have x times x0, and x0 is this one right here. So x0 is exactly this expression here. So it's gonna be x times x0 plus is this plus here, 1 plus x to multiply the x1 and the x1 x to the 7 plus x squared plus the x2, and this whole polynomial here that I'm marking there with the arrow is the x2 plus the x3, and the x3 is this polynomial here. So all I have to do now is do the simplification. The simplification we did in the Galois group. So we'll first start with normal a multiplication of polynomials, and we have to reduce according to the XOR and also the polynomial x to the 8, the important polynomial. Okay, so let's see how that goes. So let's multiply this out. So I'm going to multiply here x times x to the 6, x cubed, and times 1. So if I write down what I get from there, so let me put it down over here, I will get x to the 7th power plus x to the 4th power plus x. That's what I get. This 3 terms here is what I get from this multiplication right here. Now I'm gonna do plus the next one, and so I have to FOIL this. So let's FOIL that. So we're gonna have 1 that multiplies x to the 7 and x squared. So I'm gonna add x to the 7 plus x squared. That's multiplying the 1. I also have to multiply by the x. So I have to take this x and multiply by x to the 7 and x squared. So what I'm gonna have is I'm gonna be having an x to the 8th plus x cubed. That takes care of these 2 first multiplications here. The last 2 terms, they're just like that. I don't have to multiply by anything here. So these parentheses that you see here are actually unnecessary, so I don't need them. So I'm just gonna add this. Add here x to the 7 plus x to the 6 plus x to the 4 plus x squared, and then next polynomial, which is this one right here, will be plus x to the 7 plus x to the 6 plus x to the 5th plus x. And now what I have to do is I have to add like terms. So let's see what we have. The largest power that you see there is an x to the 8, and I cannot combine that with anything, so I'm just gonna write down x to the 8th. Let's see the powers that are x to the 7. So x to the 7, so I have one power here. I'm marking down with purple x to the 7. I have another x to the 7 here. I have another x to the 7 over there, and I have another x to the 7 there. So all the ones that I have in purple are the ones that I'm marking with x to the 7. Every pair of x to the 7s will cancel out because we are doing addition with sword. So this x to the 7 will cancel out with this one, and this x to the 7 will cancel out with that one. So I really don't have any x to the 7th at this point. Okay, let's see. Do we have any x to the 6? Let's mark those down with another color. So I'm going to use green. As you can see here, there is nothing here on this line of x to the 6. But I do have an x to the 6 here and another x to the 6 over here. So now I'm going to mark those down. This is x to the 6, x to the 6. And because this is addition with sword, then they will 1 plus 1 will be 0, so they will cancel out. Now we go to x to the 5th power. So do we have any x to the 5th powers? Yes, we have. There is only one of them, and it's right here, this x to the 5th. So I just have to add x to the 5th. I'm going to mark that with a circle to make sure that I already did that one. So it's going to be plus x to the 5th. All right, so do we have any x to the 4? So we have an x to the 4 right here, and we also have another x to the 4 right here. So those things will actually cancel out because they are x to the 4 plus x to the 4, and remember the addition here is source. So this, I'm marking this with yellow, and with yellow, the x to the 4s will cancel out. Okay. Do we have any x cubes? Yes, we do. We have an x cube, which is right here. And I have only one of those. And here an x cube. So I just have to write that down because it doesn't combine with anything. So I have an x cube there. And I'm going to circle that because I want to mark that I already did that x cube, which is right here. This is the x cube I did. I'm almost marking down the x squared. All right. So do we have any x squares here? Yes, we do. We have an x squared over here. And we also have another x squared to here. So because they are, this is addition with source. So I'm going to mark this with x squared. They will cancel out. So I don't have any x squares in the final answer. Now, okay, I also did this x to the 8. So let me mark it down. Now, do we have any x's? Yes, we do. We have an x that is right here and another x which is right here. So in this case, then they will cancel out because I'm adding the same thing twice. So it's going to have x here, and x here. So they will cancel out. And I'm actually done here. So this is done. Now, that's it. So that's it so far. But what I need to do now is I need to simplify this expression, because I cannot have any polynomial that is degree more than 7, because remember, this has to be an element of the Galois group. So remember, once you have a power that is bigger than x to the 8, there's a couple of things you can do. One is you divide it by the polynomial, or you can replace the x to the 8 by certain powers. Now remember, what we can do here is I'm going to replace, if you recall from the polynomial p of x, the polynomial p of x is x to the 8th plus x to the 4 plus x cubed plus x plus 1. And what that basically means is every time you see a power of x to the 8th, you can replace it by this whole thing that is here, by the final. So what I'm going to do is I'm going to replace this x to the 8 that I have here, I'm going to replace it by these powers that I have here. So if I do that, then we can simplify this a little bit more. So this is going to be, let's replace that by this whole thing here. So I'm going to have an x to the 4th plus x cubed plus x plus 1. That whole thing was the x to the 8th. So this whole thing here was the x to the 8th, and then I add x to the 5th. So it's going to be plus x to the 5th plus x cubed. And so what I have there is almost my answer, but I have to take care of the common terms. Now I have a couple of common terms here, which is the x cubed here and the x cubed there. So if I do that, then they will of course cancel out, because this is addition with sort, so cancel out. Okay, so in this case, what is the largest power I get? The largest power I get, of course, in this whole expression will be x to the 5th. So I'll have an x to the 5th. Then that means I did that one already, x to the 5th. And then I have an x to the 4th, which is right here, an x to the 4th. So plus x to the 4th after that. So plus x to the 4th. And I did that one already, so I did this one. And I have plus x plus 1, which is the last part that you see here, plus x plus 1. Let me write that down. Plus x plus 1. Now this will be the answer. Now if you want to know what byte this represents, remember that you can do it by doing the following thing. You have to start with x to the 7, x to the 5th, x to the 6th, x to the 5th, x to the 4, x cubed, x squared, x and 1. And then you get the byte from there by looking at these components that are here. So I have a 1 for the constant. I also have a 1 for the x. I don't have any x squares. I don't have any x cubes. I have an x to the 4. I have an x to the 5th. And I have no x to the 6 and no x to the 7. As you can see here, this is a byte. You have 1, 2, 3, 4, 5, 6, 7, 8. So this is the byte that is Z0. That it will be Z0. This guy will be Z0. So this is the first byte. Now, how do you get the other bytes? The other bytes, you get them. Let me go scroll all the way up here. The next byte, C1, that is right here, that I'm marking that with green, is gonna come from multiplying this row by the same x0, x1, x2, and x3. All right, so I will have to stop the video now, but so the next one, it has to be like that. I'm not gonna do the next one because it's exactly the same computation. You just have to do multiplication of polynomials. So that's how you transform with the mixed column. I know this is a little bit more involved. It requires a lot of algebra, but this is the way the advanced inclusive standard works. So you have to get out of this is basically just look at this matrix. This is the whole key for the mixed column. So you're gonna start with 4 bytes at a time, and I'm gonna transform by one by one. So we got Z0. The same idea works for C1, C2, C3. For example, if you were to know what Z3 is, you will have to multiply the last row by x0, x1, x2, and x3. Same thing, polynomial multiplication, and then you have to reduce it according to sort and the polynomial. So I hope this was clear for you. I know this was a lot of algebra to take in, but there is no other way to go around the mixed columns here for the advanced encryption standard. So I'm gonna stop the video now, and I will see you in the next video.